This short video is a demonstration of programming and testing motion with Omron's Sysmac Studio. It takes only 5 minutes. Let's start with a new project. We're choosing the NX102 controller model. We need a network servo drive. We can drag the servo drive into the EtherCAT network tree. Now we have hardware that we're going to use for our motion testing. Here on the left, we need an axis of motion. We have to set up a few things for the axis. The initial setting is virtual servo axis. After configuring as a real servo axis, there are automatic exclamation points reminding us that there are details to take care of. We need to assign a device to the axis. With the servo drive set up as the axis hardware, we're ready to configure the axis so we can program motion in user units. I'm choosing degrees of rotation. We need a maximum velocity, so I'm setting that up. In the lower half of the project tree on the left, there's programming. The new project starts out with Program 0, Section 0. For programming motion, we need some PLC open function blocks. The MC power function block is used for enabling torque at the shaft of the servo motor. The function block needs a name. We also need to specify the axis of motion. I can right-click Insert and Input in order to be able to enable or disable torque in the application. An input is also called a contact, like it was called in a relay circuit before we started working with PLCs and ladder logic. Now we need another rung of ladder with a function block for commanding an index motion called MC move relative. This function block also needs a name. I need to set some inputs for controlling the motion profile. I need a contact to be able to initiate the motion. There's one more thing I need. I'm going to insert one more rung and do a right-click Insert Inline ST. The inline structured text is handy for calculations. I'm going to calculate the accel decel rate in proportion to the velocity. I'm setting some initial values so when I start the simulation, it's ready to go. And now we're starting the simulation. You can see the initial values are set. I can go ahead and execute the index motion. But when I command this first motion, I get an error, and I can see that in the controller status. Here at the troubleshooting pane, I can check the error, the same with simulation as when I'm connected with hardware. I can reset the error here even during debug. I needed to energize the servo even in simulation before commanding the motion. I'm going to put in a watch tab page and monitor the axis velocity. All the monitoring and debug tools are ready to go in the simulation and work identically as with hardware. So here, when I start the motion, you can see the simulated velocity, and when the motion is done, this will change from thin to a thick green line. Now I'm going to set up a data trace. I'm going to put in two variables, the velocity and the position of the axis of motion. I'm going to make a few layout adjustments, and I'm going to set up the trace to start when the index starts. Then I can press Start Trace, this record button at the top left. At this point, it says waiting for trigger down here. When the trace starts, there will be a progress bar down there on the right of the Sysmac Studio status bar. So I'm executing the first motion, and we can see that there's progress in the data trace. The first motion finished, and we have time for a second motion in the data trace. And here's the data. The velocity in yellow, a non-zero velocity during the motion, and the position increased until the motion stopped, then resumed for the second motion. With little effort, we're able to program and demonstrate the motion with simulation in Sysmac Studio. With this short video, we have demonstrated the steps for programming a simple motion with Omron's Sysmac platform. This included monitoring functions, as well as troubleshooting, within the simulation environment of the Sysmac Studio software.